Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on linear algebra, chapter elementary transformations, lecture number 13. I will solve some problems in which I will determine the non-singular matrices P and Q to form the matrix A in the normal form PAQ. Now we solve a problem. Problem is for the matrix A matrix is 3 by 4 matrix. Find non-singular matrices P and Q such that PAQ is in normal form. Also find the rank of A. Before solving this problem, I would like to give you some ideas which will help to solve this problem. Let A be an m by n matrix, means number of rows of matrix A be m and number of columns of the matrix A be n. If we pre-multiply this matrix A by unit matrix, this unit matrix must be of size m by m, means unit matrix of order m. I be m by m size, because number of rows of A be m, number of rows of A be m, then number of columns of unit matrix must be m. So unit matrix will be size m by m. If we post multiply A by unit matrix, then this unit matrix will be of order n, means n by n. A be size m by n, number of columns of A be n, therefore number of rows of I will be n, means I will be n by n size. This is the first concept. Now let we give the second concept. This concept is given with particular example, because in particular example one can understand very easily. Let A be 3 by 4 matrix, means number of rows of A be 3 and number of columns of A be 4. So with the help of first concept, we would like to pre-multiply A by unit matrix. As here number of rows be 3, so unit matrix will be of order 3. A equal to I3A. We write value of A, value of I3, value of A. Now let us perform elementary row transformation in left hand side. We have 3 types of row transformation. Number 1 is mutually interchange of rows Ri, Rj. Next is multiply each element of any row by a non-zero number k. Number 3, add with each element of any row with some number, multiply corresponding elements of other row. 3 types of elementary row transformation. Let us perform here. First, means in left hand side we interchange first row and second row. So we write first row first, 5, 6, 7, 8. In place of second row we write first row 1, 2, 3, 4, 4, 5, 6, 7. Then in right side we interchange the first row and second row of the unit matrix. Means we write elements of second row 0, 1, 0. Elements of first row 1, 0, 0, 0, 0, 1. And this matrix remains same. 1, 2, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7. And we get the same result of left side if we perform same elementary row transformation in I3. Similarly, if we perform second kind of elementary transformation in left hand side, we perform this type of elementary transformation in I3, second or third. This is very important to remember. Now, I would like to give you the third type of concept. Let A be 3 by 4 matrix. If we post multiply A by unit matrix, then we will have to post multiply unit matrix I4, because here in A number of columns before, means in A number of columns be 4, 3 by 4. So in unit matrix this will be 4 by 4, because number of columns of A equal to number of rows of unit matrix. Now we write the values of these. A, here I4, unit matrix I4. Let us perform elementary column transformation in left hand side. We have three type of column transformation: Ci double implication Cj, number 2 Ci implication KCi, number 3 Ci implication Ci plus KCj, similar to elementary row transformations. Here we interchange. Let first be interchange of column I and column j. Here let we consider the interchange of column 2 and column 1. We write elements of column 2 in place of column 1, and we write elements of column 1 in place of column 2. Then we will have to interchange the elements of column 1 and column 2 in I4 post multiplication. So here we write elements of column 2 here, and here elements of column 1, and we will get the same result. In nutshell, if we wish to perform elementary row transformation in a matrix, then we will have to pre-multiply with the corresponding elementary matrix. This is the elementary matrix. After performing one elementary transformation in unit matrix, that matrix is called elementary matrix. So if we wish to perform any elementary row transformation in a matrix, we will have to pre-multiply by the corresponding elementary matrix. And if we perform the elementary column transformation in a matrix, we will have to post multiply the corresponding elementary matrix with that matrix. Now we start to solve our problem. Here we see that the matrix A is of size 3 by 4. Therefore, number of rows of A B3, we may pre-multiply A by unit matrix I3, since number of rows of A B3. So we may pre-multiply, means before A. Here this is A. If we pre-multiply A by unit matrix, that unit matrix will be I3, means number of columns of unit matrix equal to number of rows of A. And number of columns of A before. So we may post multiply by unit matrix I4. Here A B size 3 by 4. Here number of columns of A B 4. So if we multiply A by unit matrix, here number of rows must be 4. So this will be I4. So we may write A as A equal to I3 pre-multiplication unit matrix, A I4 post multiplication unit matrix. Here we write the values of A I3, A I4 in this line. We have to make A in normal form. So we make normal form means A will be of the form IR0, 0, 0. This form means we try to make zeros in place of 2 and in place of 3. So we have to perform elementary row transformation in place of R2 minus 2 R1, here 1. So R2 in place of R2, R2 minus 2 R1. And in place of R3, we have to perform R3 minus 3 R1. So we will get here 0. 1, 0, 0. And consequently, other elements will be affected. This is the elementary row transformation. For this, we will have to perform elementary row transformation of this I3 pre-multiplication with the corresponding elementary matrix. So we perform this elementary transformation on I3 and we get this result. In place of this, here R2 0 minus 2 R1 means minus 2. In place of this, R3 minus 3 R1 means minus 3, and other elements will be affected. And A will be same and I4 will be same, remain same. Now we will have to make here 0, here 0, here 0. Means we have to perform column transformation. So here C2, in place of C2, we will have to perform C2 minus 2C1. So here 0. Here C3, in place of C3, C3 minus 3C1. Here 0. Here C4 means minus 2 here. C4 plus 2C1 means minus 2 plus 2, 0. And here will be 0, 0, 0. This is the elementary column transformation. So we will perform same elementary column transformation in unit matrix I4 and we will get this result. Now we see that here minus 6 minus 6. If we divide this column by minus 6 means in place of C2 we write minus 1 by 6 multiply C2. Here we will get 1, here 1. Similarly here multiply minus 1 by 5. Similarly here we multiply 1 by 7 and we will get this. This is the column transformation, elementary column transformation. So we will have to perform this transformation in this matrix, post multiplication matrix, and we will get this result, and other will remain same. Here we have to make 0. Here 1, 1, we generally try to make in the form of unit matrix. We try to make the diagonal elements 1 and other elements 0. So we have to make here 0. This is the row 3. So we have to perform row 3 minus row 2. Here it will become 0. So here R3 implication R3 minus R2. So we write 1 0 0, here 0 1 1 1, and here 0 minus 0, R3 minus R2, 0 minus 0 0, here 1 minus 1 0, here 1 minus 1 0, here 1 minus 1 0. Here this is the elementary row transformation. So we will have to perform same elementary row transformation in pre-multiplied matrix. Here we have to perform this. Minus 3 minus minus 2 means minus 1 here. Here 0 minus 1 minus 1 here. Here 1 minus 0 1, and others remain same. Now we have to make here 0 0. So in place of column 3 minus column 2, and here in place of column 4 minus column 2, and here will be 0, here 0. Here we perform elementary column transformation. So we will have to perform this transformation in post multiplied matrix. We perform this in this matrix. C3 minus C2 in place of C3, in place of C4, C4 minus C2, and we will get this matrix. Here we see that we get here this matrix in the form of I2, unit matrix I2, here 0, here 0, here 0. Let us call this matrix as P and this matrix as Q. So left side is in normal form, which is equal to PAQ, where P will be this matrix and Q will be this matrix. So we find P and Q. Here this I2 represents that matrix A is of rank 2, that is rank of A equal to 2. Here we have performed elementary transformations on matrix A in left side. We know that by elementary transformation the rank of a matrix is not altered or changed. So rank of this matrix equal to rank of A. Rank of this matrix is 2. So rank of A is 2. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button. And if you have not subscribed my YouTube channel yet, then please subscribe my YouTube channel. Thank you.